Ladies and gentlemen, thank you for joining this afternoon for the final session in the LTE Impact Track. It is now my pleasure to introduce you to Jeff Mucci. Jeff is CEO and Editorial Director of RCR Wireless News. He is also the Managing Partner, Arden Operating Company, owner of RCR Wireless News and Telecom Careers, a leading industry job board founded in 1999. Over the past 20 years, Jeff has been involved in many facets of running day-to-day operations for telecom, wireless, commercial real estate, and energy services companies, and has raised over $300 million of debt and equity for companies in which he has been involved. Previous roles include Chairman and CEO of Connect South, a regional DSL company, President of a facilities-based CLEC, and Senior Vice President of Sales and Marketing for Clearwire. Jeff?
Thank you. Thank you. We'll get the gold star right there. Well, it is the end of the day. It's the last session. So thank you for coming today. Our agenda will be, I'm going to have each of the panelists introduce themselves, and thank you for the kind introduction from PCIA. And then each of us will give a 5 to 10 minute presentation, and then we're going to have Q&A. I think given the size of the audience, we'll welcome questions along the way, so please feel free to jump in at any time. So at this point, why don't we just go down with Takwa and Mavenir, just introduce yourselves if you don't mind, and talk about your role.
Sure. My name is John Hoadley, and I'm the wireless CTO at Takwa. And well, we'll go through some of the things Takwa's doing in the presentation.
I'm Bijoy Pangajakshan, and I'm Senior Director for Solution Architecture at Mavenir Systems.
Okay, well, RCR recently released a feature report on VoLTE. We named it, Where Are You, VoLTE? And I think that's the million-dollar question. Where is VoLTE and when will it be deployed? You can certainly download this feature report at rcrwireless.com. Allie Winter was the editor and writer on this. I had nothing to do with it. So in the report, we talk about the VoLTE forecast. VoLTE subscribers are expected to grow 145% compounded year over year through 2017, and that's an Infonetics quote. There are 12 commercial VoLTE networks and 8 million VoLTE customers worldwide, again projected by end of year 2013. SK Telecom is leading the way, accounting for 3.6 million VoLTE customers as of April 2013. And here's a quote from the Dell Oro Group. The most important trend underway in telecom voice today is VoLTE. It is stimulating significant spending both in the wireless infrastructure area but also in the wireline infrastructure. And I think one of my favorite quotes, and I wish I'd coined it, was you can't have wireless without wireline. Where are we today? SK Telecom is leading the market. Metro PCS launched VoLTE in August 2012. Across markets with some limited support. They've since been acquired by T-Mobile. Verizon is on track to launch service in 2014. Many carriers, according to the report, are not yet convinced of the technology and that the customers are ready for VoLTE. It's a bit of an eye chart, so I'll try to go through these quickly. VoLTE current status, LTE is part of a solution to deal with increase in mobile data traffic. We are moving from a TDM environment to an IP environment, and per my introduction, this reminds me back in 1998, 1999, 2000 era when the wireline business was moving from TDM to IP. It caused mass disruption as folks were rolling out soft switches. Terms like media gateways and session border controllers were the terms of the day. To me, and many, you're nodding your head. I mean, those were fun and interesting days as you had spent millions of dollars on TDM switches and you're migrating over to an all IP network. It was incredibly challenging. I would say in the mobile world, it's probably more complex by a factor of 3 to 10. And I think an interesting statistic about LTE, when you move from compare a TDM voice call and the number of sessions that are set up and to tear down and set up a call, you might have 6 sessions. And some of the technical guys, please correct me here. When you move to LTE Advanced and do voice over LTE, you've got upwards of 100 sessions that require management. And so you're seeing a big move, and these guys will be talking about IMS and diameter signaling and the like, and it's going to create a tremendous amount of disruption for mobile carriers. And I think the key point here, This transition is going to cause deep changes in operations and business models. And I do hope that you guys can get into some of the details about the specific challenges that the carriers are going to face. Interim solutions are available. I think from what I've heard from the market, many of these are sometimes non-standard. So you have 3GPP who set standards, but those standards are in the adoption phase and interoperability testing phase. Carriers need to deal with voice today, so there are some interim solutions. As you move from these 2G, 3G, 4G, LTE Advanced, and VoLTE networks, you have to be prepared to, or mobile carriers have to be prepared for what's called circuit fallback. So if a customer that is on a VoLTE device on a LTE network and then they roam into a network that is a 3G network, how do they deal with that call? So again, it's incredibly complex. I remember years ago, one senior executive from AT&T said, you know, wireless is easy. It's the mobility part that's hard. I think most all operators are taking the VoLTE route. Migrating from different 2G and 3G networks is where you see the variation in strategies, and that's primarily because of the different spectrum that carriers have, the types of equipment they deployed, the types of spectrum they have going forward, and that migration pattern from where they are today to where they're going. But there's no doubt that we are moving to an all IP network, and VoLTE does offer an opportunity to offer more efficient use of spectrum. So I'm going to move on to the next speaker, and if I can figure out. But Joy, why don't we start with you?
Thank you, Jeff, for moderating, and John for joining the panel. So I'll start off with giving a brief overview of Mavenir as a company. Mavenir has a solution set that's based on IMS, supporting all IP-based services. Our vision for network transformation, we've been working with operators around the world, has been to be able to deliver next-generation services that's in a fundamentally different way in which the legacy services are delivered. This in terms of scale, the cost of delivering services, and as these services are increasingly being commoditized by the OTT guys. Our strategy is also aligned in that. We want to be able to enable the operators to raise the bar in terms of services that they offer the consumers. It's pretty well known that operators have been pretty quiet or not doing much in the area of innovation. When you have social networks and other OTT guys coming out with a plethora of new services, pretty compelling services, and I'd say effectively redefining the benchmark for definition of a compelling service. And we've seen operators come to OEMs and to our vendors such as Mavenir and Taqua and Ericsson, ALU, wanting to redefine these services, being able to define the same service that are offered by the OTT guys on a one-to-one basis while still interoperating with the legacy user base. And that's one area of particular strength for Mavenir. Mavenir as a company started out in 2005, and we started as an FMC supplier, which meant that we had to deliver mobile services to IP devices. This required us to do a lot of interworking between the legacy and IP technologies. And as a product portfolio evolved, this interworking functionality was built into all of our platforms. And I stress on this fact because it's very important for LTE as initial rollouts for LTE happening around the world. The coverage is not going to be on par with legacy services. So to ensure the user experience across these different domains, we need to make sure that there's seamless interworking between these technologies across the domains. And that's an area where Mavenir has put a lot of R&D and made sure the different implementations, regardless of whether it's CDMA, IS41 based, or GSM, Camel based, we have the interworking in place for that. And because we have the first mover advantage for VoLTE and RCS, we were the first to launch IMS-based voice over Wi-Fi with T-Mobile way back in 2007. And we were also the first to launch Voice over LTE in the world with Metro PCS August 2012. And in October 2012, we launched RCS with, again with Metro PCS, and that was the first in North America. I'll spend a couple of minutes on Mavenir's product portfolio. I show the hardware-based implementation here, which is based on the Mavenir's M1 platform, which is a platform for the IMS core, the telephony application server, as well as all the application servers for delivering rich communication services. Even though these services I show here are on a hardware-based platform, I can say that Mavenir is a complete software company because all of these services are available in a virtualized environment. And this is one area where a lot of operators are now driving towards in the implementation is virtualization. It's a concept that's very well understood in the IT domain, but it's slowly working its way into other areas in the telecom field. And either the products are virtualized today, like the task and messaging server, or like the MStore server that's required for IMAP RCS, would be virtualized over the next 3 to 6 months. So at that point, I could say that Mavenir is a complete software company. I want to touch a bit on some of the challenges, and I think we'll spend some time on the panel also talking about challenges. Some of the quick ones here. Service parity, that's been a pretty challenging thing for operators. I come from an operator background. I was the corporate director at Metro PCS, leading the rollout of VoLTE and RCS before I joined Mavenir. So I have first-hand experience on some of these VoLTE challenges as we work through this at Metro PCS. The big one was service parity. It was ensuring that as VoLTE gets rolled out, the user experience stays the same. You don't lose services as you move to VoLTE. VoLTE is supposed to improve the call quality, give you better voice quality as well as call setup times. But at the same time, all the supplementary services, you need to make sure that it still works as you move to VoLTE. The VoLTE definition has been there in the MMTEL specs. There's RCS definition of best effort IP calling, and there's IR92 VoLTE calling. In all of these, there are differences. As an industry, we need to align on which approach we take, and pretty much GSMA is aligned around the IR92 implementation for VoLTE. But still, you don't see definitions of how the interworking of your legacy services will happen. That's not there in any one spec that you could go look at and implement. So a lot of time during the initial discussions with operators is spent on how you reinvest the capital that you have deployed today in your legacy network for VoLTE. And this is around the area of IS-41 IN services and how you would introduce the IMSSF. Does it come in as a separate element or does it get bundled into the task? How do you slowly roll out SIP-based functionality into your legacy networks? The customer experience, I alluded to that before. How you get to implementing that single number service is very important in VoLTE. There are different techniques available, and it's not a single solution that can work across all operators. We'll have to spend a lot of time with operators understanding how their network functions today and what could be done to route those legacy calls to IMS. And finally, a big part of it is the OSS and BSS integration. There's IMS core that you introduce for VoLTE, but at the same time, you have a legacy infrastructure with media gateways and MSCs and an OSS built around it, which you need to reuse for VoLTE. So that's another area, and then I think we'll talk about other areas such as roaming and interconnect during the panel discussion. Thank you.
Sure. Thanks, Jeff. You're quite the master of the PC now. And thanks, Bijoy. So just through the presentation, my name is John Hoadley, and through the presentation, what we'll do is I'll give you a bit of an introduction on TAQWA, talk about some of the transition steps that we see with VoLTE, some of the areas that people really have to look out for, in terms of challenges and some of the solutions that TACWA delivers as well. So just a bit of a history on TACWA. TACWA came into being in 1998, focused on voice over IP, and had a successful business and still has a strong business in rural, class 4, class 5 switching, also works with as a gateway product in the IP peering business as well. And about 4 to 5 years ago, TACWA got involved with a large CDMA carrier on their implementation of femtocells. And if you know much about femtocells, there's 2 types of femtocells in the world, those that are from the HSPA world and those that are in the CDMA world. The HSPA world, there's a interface called IUH, and it makes all the little femtocells look like small base stations, and they hook up into a kind of a RNC controller, and that's very traditional way a wireless network works. In the CDMA world, they decided to do a bit of a leap forward, and the femtocells, they wanted to make SIP endpoints. So they're using SIP technology. Now the challenge is, when you make a call off of a femtocell, you want that call to look like it's still a 3G call, like it's going over the existing core network. SS7 is the signaling. So they needed an interworking system between SIP and SS7. And so that's how we got involved with effectively what's led towards a lot of the technologies involved with VoLTE. Because as we go towards VoLTE, we're not completely leaving that 3G world behind. We have to do the interface between SIP and SS7. So that's how we got involved. That project was very successful with the lead customer. Hundreds of thousands of small cells have been rolled out, femtocells, residential, enterprise, supporting 1.5 million users and subscribers every day. So some of the key technologies that we work on are a centralized CSFB system. It was mentioned before about circuit switch fallback. Carriers are looking for circuit switch fallback when they're just introducing LTE. Something called SCCAS, which I'll talk a little bit about that, a bit of alphabet soup in terms of the technologies, but basically how do you centralize services, how do you ensure continuity, service parity, and embedded Wi-Fi. So this chart's basically a chart that I've pirated a bit of it from Qualcomm, frankly. And Qualcomm, I think, did a very good job of showing kind of that there's an evolution as we go towards LTE. There's, in the beginning, there's very spotty LTE coverage. Then there's LTE coverage islands where we're not 100% complete, and then there's Nirvana, and we're at LTEs everywhere. But as you go in terms of the transition of voice, you need different technologies, different transitional technologies in each of those steps. At the beginning, it's CSFB. Because you're not really on VoLTE, you're actually falling back and basically using circuit switch voice. The next step, SCCAS, is basically session continuity. Can I move my sessions, not necessarily voice, but can I move my sessions between the 3G and 4G world and back and forth? Kind of interesting applications in terms of moving video, transferring files, a whole variety of things. And then the final approach is now we're into the full VoLTE world, and do you need things like service parity? Do we still maintain a lot of the features that are on the 3G network? We've invested 10 to 15 years in all of our IN systems. Do we throw all that out? How do we handle E911? So there are transitional technologies along the entire piece. The final thing that we see as important that kind of goes across the whole piece is using the best access technology for voice wherever a subscriber is. Often it'll be 3G, VoLTE for sure with LTE, but also voice over Wi-Fi is a very strong transitional technology as we go along. So some of the challenges of VoLTE, I think we've hit a bunch of this already, but the first part I'll just talk basically about some of the enablers, and the next about some of the services. So some of the enablers is, do we have the user equipment with all of the right clients, and is everything in place? So, VoLTE and LTE is still a very new technology. If we look at the number of subscribers in LTE worldwide, so that's something that are the key chipset vendors, are the key device vendors building it into their devices right from the beginning. LTE coverage itself. We talked a little bit about, Jeff mentioned SKT. I was at a conference last week in London, SKT presented, and it's not 3 million subscribers that are enabled. The devices, it's 5 million they presented at the show, which is really impressive. But they're still not making, those 5 million subscribers aren't making all their calls over VoLTE, not by any stretch of the imagination, we found out. So there's still a lot of work in terms of the quality, still a lot of work of getting every device with VoLTE enabled so that you can get that whole network effect as well. So there's still quite a few challenges there, and coverage itself is one of the key things, and getting not taking a step backwards in performance. Seamless handoff, a big topic of the conference, and the 3G networks are the gold standard, and how do we ensure that we can move back and forth easily? And service continuity, domain selection, I mentioned that previously. Just hitting again on some of the things that really focus on the subscribers, service parity. A lot of the engineers at the conference, and I'm an engineer, we want to kind of just jump forward and go an all IP system, everything on IMS. It would sure make life a lot easier. Unfortunately, they had to admit the marketing department wouldn't allow them to do that, because there is a huge base of services, of connections in terms of E911, routing, everything that has been developed on the prepaid. All of those things are on systems that really can only be accessed by the 3G network today. So are there bridges that can be formed with service parity? Regulatory is one of the key things. I mean, we can't have a service that doesn't have E911 or a limited version of E911. So where does TACWA fit in and some of the transitions? If you look at the transitions, what we're really having to do is we're having to make that bridge between the all IP world and the 3G world. And the 3G world is circuit switched, it's SS7, and all of the technologies that I talked about really require that type of access between this new all IP world and the circuit switched world. And it's got to be done well. It's got to be done with we believe, a single platform that's virtualized, run on commercial servers, rack servers, blade servers. It's good news for the carrier. It's not the monolithic world that we had back in 3G and 2G, but it is a gap that has to be filled. So with that, I think I'll turn things back.
Great.
To you, Jeff.
While we're getting situated back on the panel, I'd like to maybe get a show of hands from the audience just to better understand who we have. Who's a tower developer? If you don't mind, raise your hand. Okay, and how about equipment vendor? Great. And system integrator or VAR, service company? Great. Well, before we get into our prescribed questions, I might invert this a little bit. Does anyone have a specific question about the presentations that were just given? Yes, sir.
John, you mentioned the cell edge performance, and so did Joy. Tell me about how VoLTE performs on pure LTE 4G versus the 3G, which is the CDMA to kind of lead over and keep handing off. Do you need more cell sites to get a cleaner handoff, or can 700 megahertz
Repeat the question. So if I could just repeat the question from our tower developer and owner in the audience, cell edge performance. And I think this really comes down to what impact will VoLTE have on the tower industry, really. And cell edge performance, will we need more small cells? So take her away.
So you always need more small cells, by the way. But so it depends on the carrier and what spectrum they have. So if the carrier has 700 megahertz, they're going to have excellent VoLTE coverage indoors. That's so AT&T and Verizon. I think I'm sure there were a few other winners of those bands. If you have higher band spectrum, then you could be in trouble. LTE was extremely well designed for data. I mean, you're maximizing, you're using spatial multiplexing to create multiple channels, to effectively, use multipath and really deliver as many bits as you can. There's a lot of error correction mechanisms, a lot of things that adjust. But at the cell edge, you can run into problems if you've got high band technology. So people who are running VoLTE and LTE just at the high bands, they're going to be more challenged. Now, they were more challenged in 3G as well. So, but I think it does exacerbate it a bit because of how LTE was designed. It was very much a data technology. You're putting a lot of bits down a pipe, so the power per bit is actually a little decreased. So you may have some real challenges. And we saw, with some of the results from some of the players who've introduced it in Korea, they were concerned, in terms of being able to get as reliable a handoff and as strong performance. So I think the spectrum is the key thing, whether people will need more cell sites or not.
Yeah, I'll echo that statement about the spectrum, and I think it also depends upon the technologies within VoLTE that's available on the RAN side. So very true about 700 megahertz having better indoor coverage, but VoLTE also introduced concepts like TTI bundling, which would allow you to gain up to 6 dB of additional coverage, but it's a technology that's not there today because it's a release 10 feature. So TTI bundling is one big thing that operators are looking forward to, improves their capacity. As far as CDMA versus LTE coverage, in terms of practical implementation, I'm not seeing operators actually go out and add additional cell sites just for VoLTE. So they complete the LTE optimization first, and if the LTE optimization requires them to add additional cell towers because they're in a different frequency range, and they have those built out for LTE, and then you use the technologies that's available within VoLTE to be able to deliver the same coverage. From experience at Metro, there was like a 12.5 dB difference between the LTE and CDMA coverage, and it also depends upon what power you're radiating at. And some operators are able to have ground and remote RRUs, in which case you may be able to radiate at a different power, and you might be sharing the cell sites with your legacy network, right? So you could have LTE and CDMA radio on the same site, which means that you're probably radiating at higher power to compensate for the legacy technology. That itself may not help you on LTE because the TTI for LTE is very small. It's only 1 millisecond, and when you're at the edges of the coverage, you're not able to send the bits back within that time interval. So that's what the TTI bundling will help you with. It will bundle the time to interval from 1 millisecond to up to 6 milliseconds.
Did we answer your question? I think one of the interesting comments there is more bits down the pipe, more power output. You talked about a 12.5 dB, I assume, decline, right? So what does that mean in terms of macro cells? If you lose 12.5 D, you're going to need more macro cells, not just small cell. Am I reading that correctly?
So the 12.5 dB had to do with having to share the antennas with CDMA. If you look at, for example, T-Mobile implementation, it's slightly different because you're going from GSM to LTE, in which case you're not sharing the antennas like you do with CDMA. So the 12.5 dB was very specific to one implementation example that I gave. But there's going to be dB difference between the two, which we have to address. And I don't think there's one solution that's going to address the coverage parity between LTE and CDMA, or LTE and GSM.
Just in general in the small cells, which is something that's near and dear to my heart, it's taken a while for small cells to really come about and kind of a large number of new sites to be developed for small cells. But it's on its way. And we've probably been saying this now for 5 years. But, residential small cells have done very well. Technologies like voice over Wi-Fi, we're big believers in that, and Wi-Fi offloading. Enterprise small cells have really started to kick in. And the next thing is outdoor small cells. There's a lot of locations where you can't get great coverage. You can't put an enterprise femto in because you've got mixed tenants. There's a whole variety of things, and quite a few quite a bit of work has been done by some of the European carriers especially, and some of the ones here, that one of the best ways to get in-building coverage when you've got multiple tenants and you know, a variety of different types of buildings is to go from the outside in. So the outdoor small cells and that type of tower development, you know, it's taken a long time, but it's getting there, and we're starting to see, you know, good, strong products from all the major, you know, RAN vendors in terms of, you know, Alcatel-Lucent with their light radio. Ericsson has a suite of products, Huawei. So there's, you know, Nokia, Siemens. So the products really weren't kind of fully baked until recently from an outdoor small cell perspective. But I think within the next year and a half to 2 years, we'll start to see quite a bit of that. But I'm not sure it's really driven by VoLTE. I think it's really driven by just pure data capacity and getting indoor coverage.
Right.
Yeah.
Any other questions from the audience about, please, go ahead.
My question is there a difference in the way VoLTE is deployed between a CDMA carrier like Verizon and a GSM carrier like AT&T?
I think one of the differences that you could look at for VoLTE
If you
is...
don't mind, just repeat the question.
Okay. The question was if there's a difference in the VoLTE deployment between CDMA carriers and GSM carriers. I think one of the big areas of difference would be around voice call continuity. The CDMA operators have the luxury of doing DR-VCC, which is a dual radio VCC, which has been around with voice over Wi-Fi. Most of the voice over Wi-Fi implementations that you see today is with dual radio, so you're able to move seamlessly. And the initial LTE implementations also with simultaneous voice and LTE, the SVLTE chipset provided by Qualcomm, allows you the capability to do DR-VCC. But in GSM network, per the spec, you have to use a single radio VCC. So from a technology standpoint, that's one area where I'm seeing a lot of a difference between implementations, but that's not saying that all the CDMA carriers are going to use DR-VCC. There's only a couple who are actually driving towards DR-VCC because there are SAR limitations on dual radio radiations. That's one area. The other is on the integration aspects of between your legacy network and your new LTE network, whether you're integrating between IS-41 or WIN.
Yeah, I'll just add one thing because those are great comments. I think there's a bit more urgency for many of the CDMA operators to go to VoLTE because within the device, I mean, you had there were a lot of good comments about dual radio VCC, but if you look at the cost structure of a handset, if you can take one radio out, you actually decrease the cost structure quite a bit. I'm not sure the exact numbers, but it matters a lot when you think of how many new devices are sold every single year, and that being kind of really the biggest cost component of the entire carrier's budget. So if you're a carrier like a Verizon or like a CDMA carrier who started off with dual radios, if you can go to a single radio device and eliminate that cost from your overall profit and loss statement, that's a huge benefit. So I think in many cases they really want to move. Whereas I do think some of the UMTS guys with single radio, you know, it maybe took a little bit of time to work out the kinks on that, but you know, because they've got a lower cost structure devices, they've got very well developed HSPA networks, which, you know, have circuit and voice together, and they can do kind of simultaneous voice and data today. Then I think that lessens the priority for some of those guys to move towards VoLTE. But CDMA has a strong incentive to move towards VoLTE.
Any other questions before we dive into some of our prepared questions? Okay, great. Thank you for jumping in on those questions early. I want to look at this from the carrier perspective first, and we'll talk about it from the consumer perspective, starting with the carrier. You know, and you touched on it briefly with the CDMA guys having a need, but what's really compelling the carriers to move to VoLTE? What's the catalyst? Where's the pain?
Well, I could start. I think the need actually varies between the operators. For CDMA carriers, mostly it is spectrum refarming. For GSM carriers, some of it is introducing VoLTE with rich communication services, so you have the capability to add voice to messaging, for example. That's one big driver, able to introduce wideband codec with VoLTE. Those I would think are the specific needs for a carrier. There's no one reason that would be common across all operators, other than saying that the spectral efficiency is inherent in LTE. You're able to capitalize on it and able to move to an all-IP network. But you're going to have your legacy network at the same time for roaming purposes for a certain period. You're not going to be able to sunset your legacy network right away. It's going to stay for 3 to 5 years at least. And during that period, you have to have maintained both the networks, but you slowly start refarming the spectrum that you have on legacy networks and use it for VoLTE.
Yeah, I think the number one driver is really the operational efficiencies in the end. I mean, you know, to get to basically an all IP network, I think just makes the carrier's life all that much better. You know, we've made the move to LTE. One of the big benefits, I mean, you had spectral efficiency benefits, but you also had kind of the whole EPC core benefit in terms of really kind of taking kind of where you know, very circuit switched or very kind of legacy infrastructure to kind of where wireline had gone previously. But now you need to kind of so it will happen. I think there's, you know, if you think of some of the drivers, I personally don't subscribe to the spectral efficiency driver because, you know, if you look at the number of bits that are going over our wireless networks right now, and you see studies from Ericsson and Cisco, I mean, we're already at 85% is data. So VoLTE, you know, you look at kind of these graphs and you see this little thing at the bottom, and that's voice, which is where most of us probably started. But so spectral efficiency, maybe you're going to get 30 to 40%, but 30 to 40% only on a relatively small portion of all the traffic in your network. You know, we talked about the handset benefit being a huge one. The wideband vocoder, you know, I think, you know, that's actually been introduced in a lot of 3G networks. But I do think in the end, you know, the services that you get with an all-IP network and some of the flexibility of introducing services, and then kind of all the efficiencies you can get by just having a pure IP network are things that will, you know, is really kind of the drivers. I think it'll take a bit of time. You've got to do it right, because if you screw up, you're going to hurt a lot of customers and yourself. So I think the transition may be a little longer, but it's a technologies that people have to start working on today, and kind of then, you know, introduce it and make sure that it works well as time goes on.
Well, let's flip over and talk about VoLTE from the consumer standpoint. What does the consumer get from VoLTE that they aren't currently getting?
I think if it's bundled with services like RCS, then you're getting something. You're able to incorporate voice into other communication methods. Otherwise, you're able to get better call quality. You're able to get better connect times. Those three factors, I think, would be from a consumer standpoint. Otherwise, it's built to be pretty seamless to your legacy network.
You know, I think it is pretty seamless. You definitely do get better connect times. You know, that's something that's going to be inherent. I think you have excellent flexibility in terms of the kind of the call quality in terms of the wideband vocoder. You know, there's just the ability to integrate voice and data applications, kind of create more of a UC type environment. I think is going to be quite a bit more easier with VoLTE. But a lot of the things we're trying to do is, you know, we do have a very good voice network, and we're trying to make sure that we don't lose anything along the way as well. So,
I think one thing is for certain. I use the term law of unintended consequences. So there are things when you start putting affordable smartphones in people's hands, our kids, our grandparents. And I'll never forget getting on an airplane 3 or 4 years ago, and I'm walking down the aisle and I see 2 grandparents, and they're not related, but they both got their Kindles out, and all of a sudden they're engaged in a whole nother conversation because of this device. And I remember my mother never got computers, so she passed away before smartphones were around. So all of a sudden you've got grandparents interfacing with their grandkids in different countries and being able to initiate these Skype calls and over-the-top type calls. And so I want to maybe, Bajoy, you talked about RCS and you know, how it fits in with VoLTE, and maybe extrapolate that into that user experience. Yes, the voice quality is great, but all of a sudden, if you can move from a call to a FaceTime, back to a call, talk about what that really means from a customer experience.
I think today there are enough OTT apps which give you capability to do over-the-top messaging, over-the-top video conferencing, but you're using multiple apps. I think over the period, the OTT guys are able to innovate at a better pace compared to operators. That's where they're betting their money as well, is the operators will be slow in deploying these services, and by the time they deploy, there'll be enough of a base from the OTT guys that consumers would be hesitant in moving towards the operator-provided rich communication services. But I think there are distinct advantages if the operators can deploy it. One of the big things is around QoS that you're able to provide. Let's say it's an operator-provided rich communication client compared to something like Skype. The operator has got control over his network to be able to guarantee QoS on his network, being able to prioritize the traffic from the OEM-provided client versus an over-the-top client. At the same time, you're able to work with the OEMs to expose certain APIs on the client to ensure better operation of the client. So you're most seamlessly integrated with the OEM chipset. So that's a distinct advantage of the operator-provided rich communication client compared to an OTT client. There are other advantages, more general ones, like all my communication is now still based on my phone number. I don't need a separate user ID like a Skype ID or a messaging ID. It's all based on the user MISDN. I mean, imagine a day when you pick up a phone and all you have is one client on the home page of the phone, which does your messaging, your phone calls, your internet browsing. Everything is built into it. It's all based on your phone number. That's the vision for RCS, but the big challenge is around interoperability. Unless you have other users also using RCS, then it doesn't become pervasive. You're not able to use a client even though you have it. That's the advantage that Skype has today, is it's so widespread. There's billions of users using it today. But eventually, as operators start to deploy their own versions of these rich communication clients, these advantages would be realized by the users. You have the inherent trust that's there with the operators compared to the OTT guys. Those would play into adoption of these new clients as well from the operators.
John, any commentary there on RCS and VoLTE?
Well, I think, unfortunately, RCS is just taking a bit of time for the carriers to all adopt it, because it is kind of the networking effect, and everyone's got to do the interoperability so that, we can't do it together unless both of us have the clients, both of us have accepted everything, and then, just like the original days of messaging, unless there's that ability to go between operators, then kind of the value is greatly diminished as well. So I think the industry's got a little bit of a challenge for enough critical mass to really happen with RCS. There are some interesting other things that come along with the whole IMS structure and with the whole move towards a VoLTE and SRVCC. It's a bit of a alphabet soup, as I said before, but one of the new platforms being introduced is called the SCCAS, so the Service Centralization and Continuity Application Server. So only an engineer could have come up with that. But it's an application server off of IMS, and it allows several different things. One is seamless voice call continuity between 3G and 4G, but the other one is to move your sessions. So if I'm watching a video on my device, I come home, I want to transfer that onto my TV, that type of thing can move back and forth. So there are those types of features that are beyond RCS that are, I think are quite interesting, that comes along with the entire structure of IMS, and kind of as part of the structure that allowed for VoLTE. And I do want to kind of stress one thing that BJ mentioned was QoS. I mean, QoS was something that was well thought out right from the beginning with LTE. There's 9 QCIs, they're called, and basically they outline different services and different requirements in terms of throughput the different services would have, different requirements in terms of latency. And QCI number 1, I think there is a QCI number 0, which is for signaling, but QCI number 1 is conversational voice. So it's given the top priority. And I think from a carrier's perspective, that's something an over-the-top guy can't provide. And it's something, when you think of enterprises, you think of all the vertical applications for voice and integrating it with data, that is really important in terms of VoLTE implementation. And a good thing is that with the devices and the gateways in the network, the carriers have started implementing that right from the beginning. So all the proper P-bit tagging is being done, and we're not just throwing capacity at something to solve QoS problems.
Yep. Is everybody familiar with RCS, IMS? We've thrown out some new acronyms that are other than RAN and LT. So just show of hands, do we need to go in a little more detail on RCS and IMS? Okay, we'll test you at the end of the program. We talked about challenges, so I don't want to rehash the challenges, but I would like to help folks understand the prioritization of challenges. So how would you rank what's the #1 challenge that the carriers have to face or address first in deploying VoLTE, and then maybe hit the second, third one as well?
So I think there's a variety of ones. I mean, service parity we talked about.
Get a variety one.
Yeah. Number one, I would, and I hate to say it, it's going to be the same as yours. I think it's the same as yours, was service parity. All these features have been developed in the 3G world. Literally, we have these IN systems that have been in place for a long time. We have incredible billing integration with the billing side of the house. And that's often a huge cost driver for a carrier and a huge time development. Any new service, the amount of work that has to go on to doing modifications on the billing system is quite phenomenal. So trying to, and it's a big decision, trying to kind of preserve what is needed from the 3G network and the features, which includes regulatory as well, but not make that such a cumbersome thing that you can't ever launch VoLTE, right? So how does that service parity and how does that approach get preserved? That I think is a challenge that a lot of carriers are going to have to wrestle with.
I think we've beaten service parity to death, so let me talk about something else from practical experience with VoLTE. I think when I was working at Metro, way back in 2011, October, around that time frame is when all the end-to-end testing in a stationary environment was completed for VoLTE. All the KPIs for voice calling, whether it's your call setup time, your post-dial delay, the actual voice quality, everything was met with auto-dial test in that time frame. But the VoLTE service was launched almost a year later, and the reason being it took another 8 months to get that same KPI met in the mobile conditions. There are a lot of race conditions on the RAN side as you start to do your drive tests of VoLTE, whether you've got S1 or X2 handoffs implemented. When the actual dedicated bearer for QCI1 gets set up, you might be in the middle of a handoff right at the instance when the dedicated bearer is getting set up. How does the MME and the eNode B handle that? Does it buffer the signaling? Those are areas which require development on the vendor side, which took time. And each operator, I mean, there were certain vendors involved in that project. There's other vendors and other operator networks who haven't even realized those race conditions yet. You would think that everything is looking good. You meet your 2 and 2 KPIs on SIP side. You start doing a drive test, and nobody's able to figure out where the failures are because there's not enough probes in an end-to-end network to be able to delineate and say, this is definitely something on the RAN side, or this is definitely something on the SIP side. That correlation for troubleshooting is extremely difficult. And you get around tuning the LT system. I mean, you go through a full LT optimization exercise, and then when you do VoLTE, you're again doing more down tills, you're increasing the power in some cell sites. That is again a challenge. It takes time to resolve that. It's not something that cannot be solved, but it takes time to solve that.
We had a question up front.
Yeah, I've had 2 questions. First off, as you said, as you mentioned already, RCS is taking a long time to market, right? It's a operator vendor funded standard for common communication, voice communication systems that can be standardized globally, right? But because of the length it's taken to get to market, we've got, and it's an end user technology, right? It's a client-based technology, right? But as it's taken time to get to market, another
I don't see WebRTC and RCS as two competing technologies. WebRTC allows you to do the communication natively on the web browser. Once you have multi-device, then RCS gives you the capability to do rich communication from your website using a single identity on your mobile device as well. There are gateways today available that will do the WebRTC SIP over WebSocket, or whether it's a RESTful implementation. The gateways today are available in the market. The predominant implementation is REST-based conversion to SIP and RTP. But there are inherent benefits that you're getting with WebRTC. You don't have to worry about the security aspects of it. You don't need to have separate plugins for your audio and video processing. So those capabilities are definitely there. There's I would say there's a gang that says WebRTC is all that takes for the mobile operator to win customers. But then at the end of the day, from a mobile operator perspective, the device that the consumer has that the operator controls is the handset. And on the handset, you could again have a WebRTC client on your Mozilla client on the phone. Is that going to provide you a better user experience than having a rich client on the phone that will do a lot more than a WebRTC client? For an example, presence on WebRTC is extremely complicated to do between the presence-based RESTful implementation and converting it to SIP.
Yeah, I just look at, if you look at the predominant mobile OSs are, it's Google and Apple right now in the market, it's easy for them to embed WebRTC as a client-based technology for the mobile device, right? It's part of the OS system. So from taking from web to mobile, from my perspective, you know, in terms of it being a competing technology that's going to diffuse the argument over time, as long as Google and Apple continue to be the dominating OSs in the market. Right?
Yeah, the other aspect of it is a lot of the RCS functionality is going to be bundled with VoLTE. So what I alluded to earlier, where you have a single client on your device which does all of your communications. So that client could be the RCS client with which you do the voice calling as well, and that voice calling is high definition VoLTE. In that instance, you're left at a disadvantage with just a WebRTC-based client. Those two could be complementary implementations. Whether they actually take the form of WebRTC implementation, the client on the phone itself is to be seen.
I guess my other question to you guys is, how do the operators start focusing their shift between QoS for media versus voice? You know, user behavior on voice is already getting to the point between Skype and mobile, hang up and call back, right? And there's only so much tolerance there, but what they're finding out is the tolerance is becoming less on medium, right? They actually go away from a video or media that's choppy or buffering. So as the operators look to make significant investments on the LTE side of their network to optimize media bandwidth versus voice bandwidth, how do they make that decision?
Yeah.
What's going to generate revenue for them?
So a couple comments there. So first, going back to the RCS side, I really hear you on the WebRTC as well. You know, things like presence. Do you need presence as much on a mobile device? I mean, you know, you're present or you're not. You're going to answer. You know, I think there's a lot of things WebRTC offers, and you know, you can't argue with Google and Mozilla. And should you, as a carrier, be spending more time looking at you know, how does WebRTC integrate into the devices and the rest of your full offering? So I think that you brought up a really valid point there. In terms of QoS, you know, when the standard was done, they defined the 9 QCIs, but there's actually even extensions beyond that. Do we charge for some of the data? You know, in terms of people's wanting different types of performance on the web. Sometimes I wish I could do that with my computer at home or in the office because you know, we are having less and less tolerance for data. I think they've set QCI 1 with voice being kind of a good thing, but you look at all the granularity of the different types of the definitions of the other QCIs, and it's done pretty cleverly. I actually have a hard time thinking about what other categories they'd add, even though they have allowed for these extensions. So they are setting that up. How do you monetize that? And you know, are you getting users to pay for that type of service? I mean, right now, if you looked at an LTE network, I think all the traffic's going through 1 or 2 QCIs, which are just basically data best efforts, right? In the future, you know, you can't have just one QCI consuming 90% of the traffic. You know, for it really to be meaningful and for kind of you to get it right is that you've got to have a decent spread in terms of the different QCIs and then some, making sure that you really are enforcing the latencies and the throughputs that the system's been set up for. So I think there's a lot of work in monitoring and kind of making that happen. I think the framework's there. I think it's actually kind of unique in terms of this is the first time people really are doing this kind of the right way around.
Yeah, when you introduce packet switch video telephony, you're introducing 2 additional bearers. With the VoLTE QCI for bearer is going to be QCI 1, which is a GBR-based bearer. But for video, you have the option to do GBR or a non-GBR, depending upon whether you're doing QCI 2 or 6 or 8 or 9. So since it's on a different dedicated bearer, you have the capability to be able to charge that dedicated bearer separately. Another difference that was introduced with VoIP calling that was not there in CS telephony was the capability to continue a call if the video quality is not acceptable. So during a call, you could do a SIP re-invite, change the SDP parameters to say that I'm converting from a duplex call to a simplex call. I could completely turn off the video capability by setting my port numbers to 0, in which case the call will continue as a CS call. And there are specs around what happens to the actual GBR that's allocated for audio. Can I reuse some of that for video? So there's a lot of thought process into video telephony as well as VoLTE. I mean, in fact, it's 2 different specs. One is IR92, the other is 94.
We're close to being out of time. Do we have any more questions in the audience? Okay, I would like to ask a closing question. Wi-Fi, the next generation Wi-Fi has been a big topic at this year's show, in addition to small cell. But what role does voice over Wi-Fi have, and is it complementary to 3G voice and VoLTE?
Yeah, I think it's so first, I think it's very important. You know, I think a couple things. Voice has to be felt the same by the user as it is when you're making a call over your 3G network or your 4G network. And you know, frankly, there's going to be some places where Wi-Fi provides the best coverage, and the Wi-Fi technology. You know, I think people tried to do voice over Wi-Fi back starting in 2004, 2005 with some technologies called UMA in the GSM world, and Wi-Fi wasn't as power efficient, so it sucked a lot of your juice from your phone. But as you go forward with Wi-Fi, you know, it's just incredibly innovative. You know, what are we up to? We're past AC now, so we're into double digits in terms of the different subgroups and the different innovations that go on with the standard. So the technology is much more efficient. You look at devices like Android; they're much more easy to implement these types of things on. You've got a healthy client community. So really, from a carrier's perspective, they're trying to offload a lot of data. So on Wi-Fi, why don't they also offload the voice? It can help them on roaming costs, improves the overall performance from the experience from the user's perspective. It's really about managing it well and implementing it in a seamless way compared to the rest of their calling.
I think voice over Wi-Fi can be complementary. It also depends upon the carrier strategy, whether they have a managed Wi-Fi or an unmanaged Wi-Fi. If it's unmanaged by the carrier, then you have the issue of QoS. I'm not able to guarantee the QoS. So when you set up the domain retry mechanisms, let's say I've got a VoLTE handset, and I could be forcing the user on Wi-Fi whenever he's in Wi-Fi coverage. That's one option for the carrier. The other option is I'm prompting the user to accept Wi-Fi calling. If the user is accepting it, then he's accepting the chances that he might be in choppy Wi-Fi coverage area and not getting the same QoS guarantee as on VoLTE or a circuit switch call. So that's one aspect of it. And the other area is the complexity around handoff between a packet switch handoff between VoLTE and voice over Wi-Fi. There's not any implementations today where you have an EPDG in the network doing packet data handoff. All the SRVCC handoffs that you talk about is from packet to circuit. So as you get to packet data handoffs, there are complexities in the network as well. As I move from LTE to Wi-Fi, does the telephony application server need to be updated, for example, with my new location for Wi-Fi for E911, for example? So there are complexities, but they could be made complementary, especially in a managed Wi-Fi environment. Otherwise, it's more of a user action whether to accept Wi-Fi calling or not.
Any other closing questions from the audience? Because we are out of time, but I do want to thank you for joining us. I want to thank the panelists. Mavenir filed for IPO, or filed their paperwork for an $86 million IPO, so they are a true leader in the over-the-top play and really are a true partner with many of the carriers in helping them accelerate defending their customers against some of the over-the-top guys. And on Taqwa, on the other hand, you guys you survived the 2000 era and have become a true leader in the, I would say, the small cell management. And so we've had a real pleasure of having you guys on the panel, two leaders in the space going forward. And I just want to give these guys a big hand. Thank you. Thank you.